Okay, again, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. My topic, again, for tonight will be, or for this morning, will be a random topic on mathematics. And under mathematics, this falls under the application of the so-called trigonometry or similar triangles. In here, I would like to emphasize why we say in trigonometry two right triangles are similar. Okay, let's proceed. The subject matter I will be discussing will be a random topic, so you could find this topic on my channel under the playlist. Okay, mixed topics, meaning mixed topics. It could be algebra, trigo, and other things. Okay, let's proceed. We are given a problem here. This is a practical problem, and I know many students are not so interested in the study of trigo because they don't, what they call this, visualize the importance of trigo in the computation of real life problems. One application of trigonometry in real life problems is the so-called computation of height of buildings. Okay? Okay, let's proceed. In here, we are given a figure. This is a horizontal ground. This is a high-rise building. Okay, high-rise, meaning if the ground is assumed to be horizontal for this problem, we assume that the building should also be erected vertically apart. So the ground and the building are actually perpendicular with each other. So at this location here, we could say that the angle is 90 degrees. Okay, it's 90 degrees. This part of the figure represents a fosse, and the height of the fosse is actually 20 feet. Okay, the shadow of the fosse is 5 feet. Why there is a shadow? Because there was a sun here, right? So if there is a sun, there will be a ray of the sun going down like this, right? Right? So if the ray of the sun strikes this portion of the building here and the top portion of the post, then it strikes the ground here. Okay? There will be two right triangles that will be coming out from this ray of the sun. Of course, we also assume that the post is actually erected vertically upward. So this portion here is also 90 degrees. Okay? If the shadow of the post is 5 feet and the height of the post is actually 20 feet, for this problem, it was given. And the distance of the post from the base of the building is 50 feet. The problem is asking what will be the height of the building. Okay? So this could be solved by using the study of trigonometry, and this falls under the so-called study of similar right triangles. And here I would like to derive how come the two triangles are actually similar. Okay, let's try to bring out the solution for the value of h. We are looking for h, so we bring out the solution. Of course, we are on trigonometry, so we will be encountering two right triangles. Okay, I will get my right triangle here. Hold on. I brought out my right triangle. Okay. If I would like to bring out the first right triangle here, the one on the left, we assume that this is the first right triangle. It is this one here. It is this. Okay. This is the fosse. It is vertical. This is the ground. It is horizontal. So at this location here, this should be 90 degrees. The height of the post is 20 feet. So it seems This is 20 feet. Okay? And the ground, which represents the shadow, is actually 5 feet. So it seems this is 20 feet and this is 5 feet. It's a right triangle. Okay? The second right triangle will be this one here. I press a horizontal line over here. Okay? So this is horizontal. This is the ray of the sun. So I will be bringing out this right triangle here. So if I will try to bring out the upper right triangle, upper bigger right triangle, it seems it is this one. The upper right triangle, this portion here should be h minus 20. This portion. Why h minus 20? Because this is 20 feet. The total height of the building is h. So this portion will be h minus 20. So it is represented by h minus 20. This portion. Okay. This distance here, this distance, this line here is parallel with this. So if this is 50 feet, this should also be 50 feet. Right? So this is 50 feet. That's the second right triangle. Okay? How could we say that the first right triangle is similar to the second right triangle? Under the study of similar triangles, it says that the ratio of the sides will be the same for similar right triangles. And I would like to derive that one. And to derive that one, why they are similar, why the ratios of their sides are actually similar, it is something like this. This is the ray of the sun, right? This is horizontal. This is horizontal. So if this angle here is theta, this should also be theta. Because this line here is same as this one. This is horizontal and this is horizontal. So if this is theta, this should also be theta. So on the two diagrams below, if this is theta, this should also be theta. And that's where the similarity will exist. There is a common angle for both of them. That's why they are similar. Okay. So if this is theta and this is theta, they are both right triangles, right? I will now try to take the tangent of theta, the tangent of this angle here by using the smaller right triangle. I place it here. The triangles are similar because theta are the same for both, right? This is theta, this is theta. That's why they are similar. Okay, and I will try to take the tangent of theta using the first one. Tangent of theta, you know the definition of tangent. It should be, considering this angle, it should be opposite over adjacent. So it will be the ratio 20 over 5, considering the first right triangle. And they should be equal to. Again, I will try to take this theta. This theta here is same as this one, okay? And the tangent of this angle here, using the bigger right triangle, it should be the opposite side, considering theta, over the adjacent side. So h minus 20 over 50. So this is h minus 20 over 50. Then we could erase this one now. Okay. This is where the concept of similar triangle actually emanates. Okay, this is where it emanates, that the ratio of the sides are actually the same for both. Okay, it emanates from this. Because for me, if you could not prove that they are similar, you must have to bring out the proof that why they are similar. They are similar because this theta for the first one is same as the theta for the second one. And again, I erase tangent of theta because we already have formulated the equation on how to compute for the value of h, right? This is the equation. There is only one unknown. It's capital letter H, the height of the building. So this is now where our knowledge of algebra will come out again. Okay, we cross multiply. 20 times 50, that is 20 times 50, should be equal to the product of 5 times the quantity h minus 20. Right? Simplification. We cross multiply. Simplifying, 20 times 50 will be 1000. and they should be equal to 5 times the quantity h minus 20. We are to solve for h without this 5 here on the right hand side. So we divide both sides of the equation by 5. So we multiply this one by 1 over 5. Right? So 1000 over 5 will be 200. Okay? That is actually h minus 20. If we try to compute for h now, after the transposition, it will be 20 plus 200, and the value of h will be 220 feet. Okay? So for this problem, in which the problem is asking for the height of the building, okay, the value of h is actually 220 feet. Okay, that's it, guys. Good evening from Los Angeles. This is Professor David J.